During the COVID 19 pandemic, before the vaccines were introduced, hundreds of products and treatments were pushed through the social media as coronavirus protection and COVID cure. One such product was virus shutout protection pendants, a necklace with a badge like small packet as the pendant with some unknown chemicals inside. These were claimed to protect those who wear it from catching COVID. There were other claims of protection and cure like saltwater spray, antiviral volcanic ash, and boiled betel leaves, which were advertised broadly on social media. Millions of people bought them and used them until countries started banning the sale of some of these products because they did not offer any real protection or cure. Many medical advices we get these days on social media are in the category of anecdotal claims or stories to grab our attention or attempts to sell us fake medicine. The prevalence of fake medicine is a major concern for public health officials and researchers. Fake medicine can be dangerous for two reasons. Firstly, they may not provide the desired treatment or protection against the illness and thus make us waste our time and money. And secondly, they undermine the effectiveness of real medicine due to unforeseen chemical interactions between the fake and real medicine. Remember this next time when you see a story about a miracle medicine for weight loss or diabetes or blood pressure or cancer. How do we know what works and what doesn't? Not just in the field of medicine, but also in many different areas of our life, like education and public policy. How do we find the answer to questions like, does a new method of teaching math make it easier for students to learn math? Does a newly invented medicine treat cancer better? Does a 10-minute meditation each morning reduce the anxiety of people? Does wearing a virus protection pendant protect people from catching COVID? To learn how to answer these questions, let's first look at a simple example from the field of education. A teacher proposed a new method of teaching math as a more effective one than the method currently used in schools. So, how do we determine which method of teaching math, the proposed new one or the old one, is more effective? The teacher who proposed the new method is well intentioned, but that doesn't mean that the new method is effective. To assess the effectiveness, we need to create two groups of students, fairly equal in size, to compare against each other. Students should be assigned to each group randomly so that both groups will be fairly similar. Then, for the next few quarters, students in one group will be taught math using the new method, and this group is called the experimental group. Students in the other group will be taught math in the old method, and that group is the control group. At the end of each quarter, we compare the test scores of the two groups to determine which method helped students to get better grades. Since students are assigned to the groups randomly and the comparison is done with a control group, this type of research is called a randomized controlled trial or RCT. If students and teachers know that they are using either the new method or the old method, it can create a bias in them and that would affect the accuracy of the test. So, it's better to hide this fact from them. Since we are blinding the students and teachers from this fact, it's called a double-blind randomized controlled trial. Let's look at one more example of double-blind RCT. Researchers trying to assess the effectiveness of a new cancer medicine use the same process. They create two groups and assign cancer patients randomly to each group. The group that will get the new medicine is the experimental group. The other group, which is the control group, will get a fake medicine that looks like the new medicine but has no medicinal value. It's done to limit the placebo effect. To make it a double-blind trial, the researchers will not let the patients or the healthcare workers know who got the real medicine and who got the fake medicine. Health status of everyone in both groups will be recorded on a regular basis to determine if the patients in the experimental group got better than the patients in the control group. Now, let's come back to the numerous health benefit claims that we often see on social media. Claims like, use this product to stop hair loss, or I did this and lost 20 pounds in 2 weeks. Most of these claims are just that, mere claims. A claim cannot be generalized and is not a proof without additional data and analysis. From the two examples discussed here, you know what it takes to prove a claim: a double-blind, randomized, controlled trial. We don't need to do these experiments and randomized controlled trials personally to get the answers to many of the questions we come across. We just need to understand the principles of double-blind randomized controlled trials to protect us from the avalanche of fake information around us. Once we understand the principles of RCT and how it is done, we can easily see through the fake claims and realize that they are just stories and anecdotes, and they cannot be considered as facts that we can use in our lives.